really pleased to be here. Oops.
Sorry,
I'm
that was me. I beg your pardon.
yeah, no worries. I'm really pleased to be here today to present part of my PhD research that I've been conducting in the past 3 years. So this talk today is about the topic of energy retrofit of historic and heritage buildings in New Zealand, a case study analysis. So as I mentioned, this is a partial result of my PhD. So I've been conducting these studies in the School of Architecture at Victoria University of Wellington under the supervision of Dr. Nigel Isaacs and also Dr. Fabricio Chica. So my research, oh, it just moved. My research looked from policy and practice perspectives on how specific guidelines for energy retrofit could benefit and could contribute to both heritage preservation and climate change mitigation. And the research methodology was mainly carried out through hypothetical case studies of energy retrofit of New Zealand historic and heritage buildings. Additionally, there was also a series of interviews that were conducted with local and national experts in the field, such as engineers and conservation architects. So initially from my literature review, I found a lot of material, substantial material especially from overseas, and very little about this topic in New Zealand. And internationally, there are a lot of publications that describe and advocate on the renovation of historic buildings as an opportunity to reduce associated carbon emissions. And for instance, in Europe, buildings that were built prior to 1945 represent around 30% of the European building stock. Also, there are some worldwide statistics that shows that the building sector is currently being responsible for at least 36% of the energy use and also around 30% of carbon emissions per year. So some of the existing historic buildings are in cases described as being poor. They have a kind of like a poor thermal envelope, or due also to many drafts and lack of maintenance. They can be considered really hard, inefficient, and costly to heat, which also there is an associated increase in operation carbon emissions due to this inefficiency. Therefore, countries like Europe, countries in Europe, in the US, and also in Australia, all of these places have been looking in the past 10 to 20 years on how the existing building stock can also contribute in order to reduce carbon emissions and also mitigate climate change. So part of the existing literature describe and indicate a concept, a building physics concept called deep retrofit, which is called to help reducing emissions and also preserving the historic building. So for instance, this concept looks on the whole building as a system. Therefore, as most historic buildings have what we call breathable materials, so breathable walls. So any kind of additions that are made into the envelope, such as insulation or even secondary glazing, they can alter and modify the balance. So the idea of the deep retrofit, which includes not only the insulation itself, but also considers upgrades in systems, so heating, cooling, and ventilation systems as well. All of them should be looked together in order to, at the same time, reduce emissions, but also preserve the historic fabric. Internationally, there was it has been already recognized a lot of opportunities from sensible retrofits of historic and heritage buildings in order to reduce the carbon emissions and also energy consumption. So the global CO2 reduction targets and global agreements such as the Paris Agreement, in which New Zealand has also signed, all of them have contributed somehow to the development of many documents, guidelines, and new policies targeting energy efficiency in historic and heritage buildings. So for instance, in this image, we can see that this is a historic England guideline about energy efficiency in historic buildings and how to improve the energy efficiency. Historic England has another series of guidelines more specifically to solid walls or buildings with solid walls, buildings with cavity walls, how to add secondary glazing to existing buildings. So there is a lot of material that we can find in their website. There are also other kinds of guidelines and books that have been published in this last 10 years. So this is an example of the Passive House Institute that published all together with a European research group about energy efficiency solutions for historic buildings, a handbook. So this book, for instance, sets up a series of principles and also minimal guidelines, minimal guidance, generic procedures, and also some examples of best practice, things that have been already done in Europe mainly. This is a important document that was also published in 2017. It's a European standard guidelines, voluntarily guideline adopted in most of the countries in Europe. So it also sets some guidelines for improving energy efficiency in historic buildings, considering not only the aim of reducing energy, but also, and more importantly, on how to preserve and keep the heritage significance and values at the same time. This is a more recent one from 2019. This is the American ASHRAE guideline, which also sets a series of procedures and instructions on how to conduct energy renovation, considering both of these challenges. And overseas, there are also a lot of what we call decision-making tools. So there are some online tools that we can have access. So these ones, for instance, is from the UK. It's from the Sustainable Tradition Buildings Alliance. So you can go online, for instance, and you can check which is the type of heritage, if it's grade 1, 2, the conditions of the building, if it's in good conditions, if it's in bad conditions, the exposure, energy type, and depending on the analysis, the first analysis, you consider the 3 main topics. So which is the fabric of the building, the services, and also the behavior of the occupants. So this is in line with that concept of the deep retrofit or the whole house retrofit, which we also call like this. So for instance, you can pick up, for instance, some of the measures that are going to be applicable to that retrofit in terms of wall measures, insulation on roof, floor, and even the services. So which kind of heat generation it's available, heat distribution, lighting, ventilation, and also the people interaction. So all of these components, after you pick up some of them, you can have a summary of what we call technical concerns, heritage concerns, and energy concerns. So these are some examples of existing guidelines and documents that are already available overseas, mainly from Europe and in the US. So additionally to these guidelines, these existing guidelines, in the international context, the energy renovation benefits from a conservation perspective were also highlighted and discussed in many projects. So for instance, in 2015, Giovannini Carbonara, who is a Italian conservation theorist, he stated and he had advocated that energy renovation could be also used as a protection tool for buildings, for keeping, preserving, and maintaining the buildings. there are also some movements that have emerged in this past year. So this is, for instance, the retrofit first, and the quote that I think most of you probably have heard about, the greenest building is the one that already exists, which mainly advocates on retrofitting instead of demolishing and building new. And more recently, last year in 22nd of March, it was published the European Cultural Heritage Green Paper that was produced by the Europa Nostra in close cooperation with the ICOMOS and also the Climate Change Heritage Network. Um, these complementary perspectives on the energy renovation of historic buildings consider the goal of energy improvements, but not only in terms of energy savings, and more importantly, they are advocating and they are looking on protecting and enlarging the use of the building, and while preserving and also enhancing the significant values. So coming to New Zealand and to the New Zealand context, in New Zealand, historic buildings are facing demolition threats, despite the growing numbers of buildings added to the regional plans, as we can see from this graph, um, which is actually the way that you can ensure protection to the heritage buildings in the country. Additionally, we can also see from this next image in this next graph that excluding earthquakes, many heritage buildings are being demolished due to redevelopments, which you can see here in blue, and also due to fire or even other reasons that can be, for instance, the buildings being neglected or even that not fit for purpose. So there is a great potential in the country that energy renovations could contribute to upgrade these buildings and likely extend their life, their use, or even their adaptive reuse. However, a lot of the existing historic buildings in the country still remain untouched by energy upgrades due to the lack of required compliance for energy efficiency, as well as exemptions of the if practicable clauses in the mandatory New Zealand Building Code. Also, in 2019, the Climate Change Act set up some targets, such as net zero emissions in the country by 2050, which are starting to have some effects in the building industry. So in 2020, the MB has published and has started this program of building for climate change, which at the moment it's mainly applicable for not existing to new constructions, but they are already setting up, for instance, carbon caps or more efficient measures and uh, um, more requirements in terms of energy efficiency. But there is also a plan for the future and the next step that this program will also tackle existing buildings, but it's still in the process of discussions. There is nothing set up yet. And unlikely the overseas examples that I shared, the guidelines, the decision-making tools. There is nothing similar here in the country on how to sympathetically retrofit energy retrofit historic and heritage buildings. So the development of a specific renovation guidance could provide help to fight, for instance, against these growing threats of new developments in urban and provincial areas, the lack of economic use for some of the historic buildings. They are not fit for purpose, buildings that are neglected or even earthquake prone, and even the ones that consider some of these buildings being cold, damp, and unhealthy for occupants. So the sympathetic energy retrofit that uses compatible heritage solutions can allow ongoing use and promote historic building conservation. And in addition to this practice, it could also contribute to lowering the carbon emissions and providing alternative aid for the country targets of zero emissions by 2050. So therefore, given this limited practice and research in this specific field of energy retrofits in the country, my PhD research was investigating, is looking on how this specifically the development or the adoption of specific guidelines for energy retrofit in the country, how this could contribute and how this guidelines should also look like. So my research question focused on how could New Zealand benefit with the use of energy efficiency guidelines. And for that, I also needed to test existing models, so based on the international literature, and see what will be the challenges and how this, and also what will be the benefits of adopting and implementing this in the country. So given the limited guidelines and the non-existence of specific guidelines in the country, I've used mainly the European document that was published in 2017. So the research focused on important assessment criteria, also on analysis such as the comfort of occupants after energy improvements are carried out, how will be the carbon emissions and energy use, and even the cost reductions on the energy retrofit process, and also how to understand, and understanding how all of these different criteria can affect the decision-making process. So these were the three main case studies, the hypothetical case studies that I used in this research. So the first one here is the Chevening Apartments, all of them located in Wellington. So the first was the Chevening Apartments, the second one's the First Custodian House, and the third one was the Tumble House. So I gathered data regarding year, architect, the use, material, how many stories, owner, if the building is protected or not. So all of these three buildings are scheduled in the district plan, and two of them actually are only in the list of the Heritage New Zealand. The Custodian House, which is owned by the City Council, it's not in the list. Some of them have had gone through some partially energy retrofits, such as addition of, for instance, in the Chevening Apartments, insulation in the south walls, or even the Custodian House, it was added insulation on the roof and also on the floor. So I gathered all this documentation and I built what we call an energy model. So I could trial some energy retrofit scenarios. So the research firstly examined measures for improving the building envelope, such as adding insulation to walls, to floor, to the roof, retrofitting windows, or even adding the secondary glazing. And all of these options were looked in order to improve the indoor quality of the indoor environment for the occupants, enlarging the life use of these buildings, and also reducing the greenhouse gas emissions and energy use, at the same time as also looking for protecting and keeping the heritage significance. So these are the retrofit scenarios that start with A to I, and basically the A is the base model, which is the existing building with the current characteristics. Then the first three scenarios were mainly focused on windows in a first instance. Then I also looked on single measures for the envelope, for walls, for the roof, for the floor. And then the last options, the last iterations are regarding the deep retrofit concept. So looking on the whole envelope as a whole component, and also options of airtighting the envelope and having the heating set up also all together with these measures. So the findings from all these 3 case studies, which we can see here from these graphs. So these are results from indoor thermal comfort. So how it improved from comparing the A, which is the base scenario, and the far we go to the last options, we can see that there are more green colors here, which means that the interior of these buildings are more comfortable in terms of temperatures. Um, so the findings confirm the lifespan benefits of energy renovation, as all had reductions in energy use, carbon emissions, and cost. The improvements also created an improved indoor thermal comfort environment, as we could see in the 3 graphs before. And these quantitative results supported the international literature as well that advocated that the deep retrofit, so the more the envelope is addressed, the oh sorry, it's going on, and the more the envelope is addressed, the better are the results that we can get. So also from this image here, we can see these are savings in heating energy, these are savings in carbon emissions, and the last one are savings even in cost, considering the life cycle of the building. So we can see from the measures from F to G, in most of these buildings, we could get in turn around 70, 50%, for instance, in the timber frame house, and in the solid wall buildings, we could get almost close to or even more than 70% in savings from energy, carbon, and also costs. So these quantitative results from the dynamic simulation, the life cycle carbon and the life cycle cost, review energy, carbon, and cost savings benefits from the deep energy retrofit, but also identified some uncertainties and challenges regarding the methods that I will talk about a little bit further. Uh, Among the benefits, it was identified that all investigated heritage buildings were considered there were considerable energy savings and indoor environmental quality improvements, despite the differences in building size, use, and materials. So the LCA, the life cycle analysis results, this graph here refers to the custodian house, which was the timber frame house example, the second case study. So the life cycle analysis results show that most the savings are a result from the reduced operational heating energy. So in this graph here, we can see in yellow is the product stage and maintenance and replacement, which refer to the embodied energy, to the embodied phase. And in the blue one is are the results regarding the operational phase. So mainly the energy that's being used or the carbon emissions related to heating the building. So the operational phase is the mainly reason or the main contributor to the results and to the savings. And the same also happens with the life cycle costs. So we can see that most of the costs regards to the operational costs, so the cost for heating the building, compared, for instance, to the investment costs. Um, so, for instance, in this example here, the custodian house, the embodied carbon portion in the whole life cycle was increased from 20% to 34% when the service life of materials was halved. So this also showed that embodied carbon, the carbon related regarding the product stage and maintenance of materials, it's also important to be assessed. Therefore, there is an importance of carrying out life cycle analysis. So not only considering the operational phase, but considering all the stages in the process. However, it was found as well that the life cycle analysis, there are some uncertainties that are associated with the long periods of analysis, such as future energy and material costs, and even the carbon associated emissions. Uh, Unfortunately, there are very few available tools that consider those uncertainties aspects. It was also found that there is a need for more precise and local information and carbon footprint databases, especially regarding materials, the material service life. So how is their length of life? And as this can also have a big influence in the proportion of results. Additionally, the deep retrofit was also identified, as we can see here in the red box. So these are the results from deep retrofit measures, that they are more effective in terms of energy savings and improved comfort, but it can also, if there are some challenges associated with the deep retrofit, because they may also require some practical challenges. So for instance, the need for more mechanical ventilation, and in case of historic buildings, this needs to have like the trade-offs to understand what can be done and what cannot be done in terms of affecting the heritage significance of the place. So after the quantitative analysis was carried out, all of these results and graphs, all of these were shown to the group of experts, and also following what was indicated by the European guidelines that are proposed to be used by many stakeholders involved in the renovation process. So this study also include these interviews in order to have many stakeholders with different backgrounds, so we can understand each expert perspective. So the interviews investigated the practicality of adopting tailored guidelines, the difference between different professionals' points of view, the challenges which arise from this, and what needs to be dealt before implementing guidelines in the country. So the findings regarding renovation process, tools, and decision making in future, this could be maybe incorporated in country tailored guidelines. So one of the key interview findings from a conservation perspective is that there is no one solution fits all, but energy retrofitting historic buildings was also considered by all experts as a way of protecting and assuring their longer term use, as well as having environmental benefits. The experts consider that historic buildings should not be exempt from energy efficiency requirements, but policies should also allow flexible targets, even if it only by small improvements. So the first topic of findings from the interview showed that from a heritage impact of proposed measures and the trade-offs, it was found the need for more careful approach in higher significant buildings. That was also confirmed an international finding, that there is a less negotiation space uh, compared to lower significant buildings. So the higher the significance in the building, the less allowance, for instance, for energy efficiency measures or even for the whole deep retrofit. So, for instance, the case study 3, the Turnbull House, which is a national highly significant building in the country, it was the only building among the three of them that had secondary glazing chosen as a preferred option. And also there was the option, it was chosen only to insulate floor and roof, which is due to the high significance of the historic and the historic fabric. In buildings, on the other hand, in buildings with a residential use, uh, and also with local significance, such as, for instance, the case 32, which is the custodian house in Wellington, the deep retrofit scenarios were more likely acceptable. So, for instance, in the timber frame house, it was preferred the use of cavity insulation, even regardless the loss of the existing plasterboard. And in the case of the solid walls, the first building, the Chevening apartments, the internal insulation was also preferred compared to external insulation. So this was confirmed as a least intrusive choice, mainly because of the heritage legal constraints that often protect the exterior facades, which was also similar to the international findings. Broader outcomes may be achieved in energy renovations if the overall heritage significance, so considering both tangible and intangible values, that can allow maybe trade-offs and even the use of measures that in some cases may not be reversible. So it was somehow perceived by these results that many timber frame houses in the country that have similar characteristics, for instance, to the custodian house and have also a local level of significance, they may have more flexible trade-offs. But again, it's always a case-by-case analysis. The second topic of findings regarding conservation principles and heritage impact assessment revealed that a minimum requirement before adding any materials to the building, such as insulation, for instance, to the walls, that these materials need to be compatible, and more specifically, they must have hygrothermal compatibility in order to avoid any kind of moisture damages or to the existing fabric. Moreover, it was also found that a comprehensive conservation plan is a really important document for understanding the heritage values and also for supporting a heritage impact assessment. And it was also indicated that existing methods of heritage impact assessment, such as the ones provided in the Heritage New Zealand website, or even international heritage impact assessment documents provided by the ICOMOS. All of this could be used and should be used in the process of energy renovation. And the heritage impact assessment, according to all conservation experts, was the primary driver for all the decisions. Uh, the third topic of findings regarding the retrofit assessment criteria confirmed that it's always a heritage values based assessment in the first place. Um, and additionally to the heritage impact assessment, other assessments such as life cycle, carbon analysis, life cycle costs were often considered the most influential in decision making following the heritage decisions, but they also have some practical challenges. So the life cycle was described in all rounds of interviews for all buildings as a beneficial assisting tool for promoting better quality materials, low embodied carbon materials, and longer last materials, as well as also helping reducing investment cost barriers, because you can see the long-term benefits while implementing some of these more costly, initially costly measures. And also the thermal comfort for occupants was also considered extremely important, but more specifically for residential buildings, especially due to the health outcomes that they provide. The last topic of findings in the interviews revealed both opportunities and challenges of adopting specific policies and even specific retrofit guidelines in the country. So the professionals, the experts in the interviews approved the bulk of existing documents and technical guides already existing from overseas mainly, but they also confirmed that there is a need for country-specific procedures and also technical examples for retrofit solutions that are tailored to the country. So experts supported the development of a retrofit policy for historic buildings, but with flexible energy efficiency requirements, for instance, allowing energy improvements, even if they are, for instance, below the minimum threshold of modern energy standards. And they also expressed the need for more training in both building performance and historic conservation fields in order to diminish, to reduce the future risks for that energy retrofits can cause to the building, historic building conservation. So experts agree the energy retrofits can help protect and assure the historic buildings use for longer periods, as well as saving their embodied carbon. Beyond the possible benefits of adopting tailor-made guidelines, the experts also reveal many challenges related with this implementation. So, for instance, it was found that the lack of experience in tools, in methods, such as the life cycle analysis, life cycle cost, and also the energy simulation and the energy analysis. So it was found a lack of experience and a poor understanding, an overall poor understanding on the historic building performance from the whole industry. Therefore, training and proper guidance are required, as well as this somehow standardized or simplified methods and tools in order to put this idea in practice. Moreover, existing international best practice examples of solutions are not 100% replicable to the local construction. So timber frame, for instance, was recognized as a challenge of using existing technical overseas guides. So there is the need for developing in specific national guides for timber frame buildings, for instance. And also there is a need for training in both fields, and more importantly, bringing both fields together, the energy performance and building performance all together with the historic conservation field. So the conclusions for the preliminary conclusions of the research suggest that New Zealand can learn from international guidance when dealing with retrofits of historic and heritage buildings. However, there is this need of adapting and adjusting guidelines to the local climate, to the local requirements, to the national standards, and also materials. It was also identified the many benefits, for instance, of the deep retrofit, because they have greater impact comparing, for instance, with just single measures. So the careful use of deep retrofit approach and measures, so combining at the same time envelope insulation, but also including ventilation in order to avoid, for instance, mold growth or interstitial condensation. This should be looked all together. The life cycle analysis was considered a beneficial tool to be implemented in order to promote better quality materials, low carbon materials, and longer lasting materials. And it was also revealed that it would be beneficial to develop, for instance, flexible national policies in order to have these energy improvements in historic buildings. However, specific guidelines would not be enough. So more than guidelines, there is the need for training, there is a need for adapting methods and tools. There is also need for creating best practice databases where people can share what has gone wrong and what is working. So all of this material together can effectively help having a good and a best practice of energy retrofit, so we can save energy, reduce carbon emissions, but at the same time, keep and maintain the historic significance and the values of the buildings. Thank you for listening to me, and I'm happy to answering any questions.
Thank you, Rachel. What a absolutely fascinating talk. I mean, I'm obviously no architect, so I got so much out of that. So goodness knows just how absolutely absorbing that would have been for the architects and technicians listening. I think stating the blindingly obvious is increasing conversations about housing, climate change, population pressure growth, pressure on heritage, all of that stuff is front and center. And so this kind of research and the robust data and findings that you and colleagues are increasingly building a database of is just going to become more and more important, both to the heritage sector, but actually just to New Zealand in general. I have a few questions sitting here on Slido. Remember, folks, you can send your questions through on Slido or just on the chat function on Zoom. It doesn't matter which one. Rachel, the first question, the person has said, great talk. Thanks, Rachel. Yeah, agree with that. Have you come across any good guidance on modernist buildings, so 1950s and 1960s?
Specifically from my literature review, there was nothing that was covering only modernist buildings. But during my research, I think I was once in an event from American historian that he was talking about specifically, it was a book only about examples of modernist buildings that have been already kind of like refurbished or maintained. So I think there are definitely there's some material there, but in these ones that I mentioned here during the presentation, they were not specifically focusing on modernist buildings.
And presumably, too, all around the world, the bodies of data are just increasing all the time. So
yeah,
someone somewhere will be presumably addressing modernist buildings as we speak. Rachel, next question. What software was used to undertake the calculations to determine the benefits of the various retrofit concepts?
Okay, so there were three different analysis. So for instance, for the energy analysis, I used the Energy Plus, which is a energy calculator, and dynamic simulation software. For the life cycle analysis, for the carbon analysis, for instance, I use the LCA Quick, which is a software from Brands, which is available. It's free and available for everyone. And for the cost analysis, I mainly base the calculations on the Rolling Stones handbook.
I'm not sure how familiar or not people will be with those various sources. So, Rachel, I'm wondering if you could even email the links for those sources to me,
Sure.
and then I can disseminate them around the group.
Yeah, sure.
That'd be fantastic. Thank you. Third question. What are some quick wins that can be done for increasing the energy efficiency of heritage buildings?
Some quick
wins. So I guess okay. quick tasks or quick processes.
So I think from the results, it was clear that the more you can tackle the building, so as a whole envelope. So instead of, for instance, looking on improving just windows or improving just walls or roof, if you can do a little bit of improvements in each of them, definitely it's a win. So simple measures such as draft proofing, which are already recommended in most of the conservation guidance. So the idea of even having like internal blinds, which is also more in align with the conservation and compatible measures. But if you can do more than that, so for instance, having internal secondary glazing, all of these measures, and like, I think the main thing is keeping maintenance. So having your building in good maintenance, it's definitely something that will also reduce, for instance, having a big cost of renovating in the future. So if you can keep doing minimal things through time, and if you have the budget, if you have the time, of course, the best thing would be having the whole house somehow isolated. So having insulation, all of the envelope, improving ventilation. So reminding occupants of opening the windows so you can reduce moisture content in the inside of the house. Yeah, I think that's a little bit of it.
Thank you. And next question, I think this is a really interesting one. Is there any interventions that you found were not successful or which ended up having a greater adverse effect on heritage fabric?
Yeah, so for instance, in the case studies that I conducted, most of the materials that I was proposing were mainly indicated from overseas literature. So one of the things that I came across a lot was the idea of compatibility of insulation, for instance. So having insulating materials that are permeable. So that's something that definitely needs to be be have a great attention or a careness when you're looking in retrofits, because any kind of materials that you're adding to the existing walls, roof, it can have an adverse effect if they are not compatible. So for instance, in terms of walls that we consider that are breathable walls, for instance, brick walls, if you use certain types of insulation that will not allow the movement of moisture and air, you can, instead of helping the building to reduce energy or enlarge its life, you're actually doing the opposite. You're probably going to have further and future issues. So one of the key findings I think from this research was looking on compatible materials, and especially hygrothermal compatible materials.
Thank you. Two final questions, which I think can almost be bundled together. So the first one was, where can we find other guidance or resources, possibly internationally, about this? And then the second was a comment, it would be appreciated if Rachel can share links to the international documents that she presented. So I think with both those questions, Rachel, if you could bundle up links, sources, reference, and all the rest, we will, disseminate those out. So clearly lots of interest in following up on this, of getting the sources, getting the material. No surprises, because as we said before, it's topics and concepts that are just so front and center with what our communities are facing at the moment. So look, we're just after 1 o'clock. I think we'll call this one quits now. Oh, and a message has just come in, an amazing undertaking. Well done, Rachel. That's from Pam. So yeah, I think everyone
thank you.
nodding and smiling in agreement with that one. Rachel, thank you for a really fascinating presentation, but also, again, one that is just so jolly relevant to the work that so many heritage practitioners do. So incredibly useful and valuable resources that people will be, I would imagine, very anxious to get their paws on and follow up on. So folks, our final Heritage Bites next Friday, which will be Suzanne Rawson, who is talking about her PhD research too on maritime underwater heritage in Taranaki. So hopefully see you all next week at 12:15 for that one. Okay, and happy Anzac weekend. Have a nice long weekend, everyone. Okay, ka kite.
Thank you.